Hello students, welcome to the first video of this new playlist. So in this playlist, I'll be solving the most recent paper of mechanics, that is October 2024 paper. So this is the most recent paper of mechanics that is available now. So this will be a special playlist since we will be solving a totally new paper, that is October 2024 M1, the most latest paper. So I hope uh, you all will understand this solution video. And yeah, under this playlist you will have 7 videos where in each of the videos I'll be solving the each of the questions of this paper. So in each of the video you will get solution to each of the questions, and wherever you find problem, feel free to comment below in the comment box of that specific video. So let's get started with the first question of this paper, that is October 2024 mechanics 1 paper. Right at first, question number 1, you can see the concepts behind question number 1. It's from momentum and impulse that has been discussed in uh, chapter number 6 of your mechanics 1 textbook. So in order to be able to solve this question, definitely you should have idea and concepts about chapter number 6, which is momentum and impulse. So let's get started with question number 1. So they are saying here particle A has mass 4m and particle B has mass 3m. So two particles 4m and 3m. Remember, for impulse and momentum and impulse questions, always try to consider the sketch. It's very effective if you consider the sketch. So let us consider two particles A and B, isn't it? So particle A goes there, okay, and B goes there. So how they are moving? The particles are moving in opposite directions. They are moving opposite to each other along the same straight line on a smooth horizontal surface when they collide directly. So they are moving opposite to each other. This is particle A, this is particle B. So they are moving what? Opposite to each other. One moves in this direction, the other one in that direction. Okay, fine. Fair enough. Immediately before the collision, the speed of A is twice of x and the speed of B is x. Okay, so we got the initial speed of A. This is what? Twice of x. If you consider u1, this is what? Twice of x. And u2, this is what? Just x. Okay. Immediately after the collision, the speed of A is y and the speed of B is 5y. Okay, the direction of motion of each particle is reversed as a result of the what? Collision. So after the collision, their direction has been reversed. So particle A will be moving the opposite way, okay, and particle B will be moving the opposite way. Okay, so after the collision, V1 is given as what? It's y, okay, it's y, and the speed of B is what? V2, which is 5y. This is the scenario. Okay, so part A asks here to show that y equals to what? 5 over 11 x. Okay, we need to show that y equals to 5 over 11 x. Y is what? Y is the speed of particle A after the collision. So for momentum and impulse, what we know, we always consider what? The law of conservation of momentum. Okay, so using uh, conservation law of momentum, what we can write? The total momentum of a system before and after collision should remain what? Same, isn't it? Should remain equal. Momentum, the before collision, what was their momentum? M1 U1, isn't it? So M1 is the mass of particle A. This is 4m. Okay, we took this direction. Before you apply the law of conservation of momentum, take one direction as positive. So we will be taking this direction as positive. Okay, so m1 u1, so m1 is 4m. Initial velocity of particle A is what? Twice of u, and that's twice of x. It's in the positive direction, so that's why positive 2x. Okay, particle B, it's moving in the opposite direction before the collision, so its velocity will be negative, and its mass is 3m. So 3m, what? 3mx equals to, after the collision, particle A is moving in the negative direction, so that would be what? Negative 4my, and particle B get reversed after the collision, and it's now moving in the positive direction, so plus what? 5 times 3. So what's 3? 3m, 3m times what? 5y. Okay, now we need the value for what? We need the value for y. Okay, so this is equals to what? 3 times 5, which is 15 my minus 4 my. Okay, so simplify the equation. uh, we need 15 my. We need to make y the subject because they asked to show that y, isn't it? Okay, so 15 mi minus 4 mi, this is 11y. M cancels out from both sides, so 8mx minus 3mx, which gives you 5x. Sorry, m gets cancelled, so what we will get here, y equals to 5 over 11 what? X. And that's what exactly question A, question number 1 part A has looked for. Okay, next is part B. In part B, the question asks to find in terms of m and x the magnitude of the impulse received by A in the collision. Impulse. Impulse is what? Impulse is basically change of momentum. So impulse received by A. So who is giving that impulse? The impulse received by A, it is basically due to the force of particle B on particle A during the collision. Okay? Okay, fine. So we need to find out what's the amount of impulse that is received by particle A in the collision. In terms of mx, we have to represent it. Okay, impulse is a vector quantity because impulse is what? Change in momentum. So change in momentum is a vector, so change will be definitely what? Vector. So since it's a vector quantity, at the beginning you need to consider the direction which you took as positive. We took which direction as positive? We took to the right as positive. Okay, so right direction will remain positive. So impulse on A, so I of A, this is what? Impulse is change in momentum, so I del P, isn't it? Del P will be what? Mv minus Mu. Remember the vector, since this is a vector, so direction matters. Okay, so we are considering impulse on A, so mass would be for which one? Definitely particle A. So mass of particle A is what? 4m. So 4m times what? V minus u. So after the collision, the speed of particle A is in the opposite direction, in the negative direction, right? So that's why it will be negative of what? Y. That is negative 5 over 11 x. And v minus u, right? So before the collision, that is u, particle A was moving in the positive direction, right? So that's why that would be what? Negative twice of x. Fine. So impulse on A would be 4m times what? Negative 5 over 11. Use your calculator. Negative 5 over 11. Negative 2. So that would give you negative 27. Negative 27 over 11 x. So what you will get here, then times 4, that would give you negative 108 over 11 what? Mx. That much. What's the unit of impulse? Change in momentum. So the unit of momentum is what? Kg meter per second, or you can say Newton second. Both will work. So magnitude, they wanted the magnitude, so if you give the final answer in negative, it will be not accepted. Okay, so the magnitude of impulse received by A, this is what? 108 over 11 mx, right? Mx, that much what? Newton second. Okay, so we got the magnitude of impulse received by A. This is 108 over 11 mx, and that's what exactly question number 1b has asked for.